Hey everyone, in today's video we're going to talk about something which I think hasn't received enough attention. So the other day, Thinking Machines, one of the AI labs, released an article called A Safe Path to Open Weights. In it, they talk about some of their thinking around how they've approached open weight AI model development and some of the issues that exist in this trade-off between AI risk and AI reward in the form of open weight models we can run and fine-tune ourselves and closed weight models that are a bit more locked down. We're just going to read through and I'm going to share some of my comments and observations. And what I want you to do is, if you have thoughts on open weight models, I want you to drop a comment below and let me know what you think about this perspective that Thinking Machines have put out into the world. Let's get into it. A Safe Path to Open Weights, Thinking Machines, July 31st, 2026. Safe open weight models are public goods as they put AI development and safety work in many hands and make training choices inspectable. Open models also carry real misuse risks and release is irreversible. To release safely, we must consider both the model and the ecosystem it enters. For the model, we conduct robust safety testing and research whether dangerous capabilities can be decoupled from general intelligence. For the ecosystem, we invest in its readiness through staged releases, supporting defenders, and collaboration with safety researchers. By iteratively choosing the most open option the evidence supports, while building up this ecosystem's resilience, we can move towards openness safely. So here they're talking about the mission of Thinking Machines is to build AI that extends human will and judgment. In pursuit of that mission, we recently released Inkling and Inkling Small. If you haven't tried out these two models, they're quite fun to use. Strong open weight models put AI development in many hands. We believe that this is a good thing. The knowledge of what AI should do lives with the people doing the work, so they should be able to shape their models directly. All models, including our own, carry the assumptions and biases of those who trained it. Open weights make those choices inspectable and revisable. Without strong open models, training and deployment expertise risks becoming concentrated in a few labs, leaving everyone else less able to understand, adapt, or govern the technology. This is such an important opening. Open weight models are a key part of this ecosystem, and we need to understand how AI is working under the hood and how all of this is put together, because the more people looking at something, the easier it's going to be to manage and mitigate some of these risks. That's a perspective that a lot of people in the AI safety space push back on, but my take is that given how much of open source our world relies on and how much more secure open source is relative to closed source, if you look at some of the history of how the open source community has evolved and the fact that almost everything essential runs on open source code. In the AI era, open weight models that people can inspect and fine-tune are a key enabler of an ecosystem that spreads the benefits of general intelligence to more people. There are risks, and that's what we'll look at next in what they've written about. Once open weights are public, anyone can use them, including bad actors. Cybersecurity shows what this means. In April 2026, Anthropic reported that Claude Mythos Preview found thousands of previously unknown vulnerabilities across every major operating system and browser and wrote working exploits without human guidance. Systems like this could substantially lower the time, cost, and expertise required for offensive cyber operations. Will our society be safer when open weights models allow everyone to have superhuman cybersecurity skills? This is a great question because equalizing that attacker-defender skill and capability balance is really important, and I think given some of the security incidents we've seen in recent weeks, the importance of open weight models where a safety classifier doesn't stop you in the middle of a cyber incident response is going to be increasingly a consideration that a lot of cybersecurity folks using AI models take into account and could lead to a preference for open weight models. Let's continue. There are genuine uncertainties around the net effect of open weights on security and the offence-defence balance. These models could find and patch vulnerabilities before offenders do when they're in defenders' hands. But the same capabilities could accelerate exploitations across large numbers of unpatched systems when they are in attackers' hands. Similar trade-offs exist in other dual-use domains like chemistry and biology. Given these uncertainties, releasing weights indiscriminately is not a safe path forward. Okay, so this is the sort of trade-off balance point that they're talking about. Some of the worst potential dual-use risks can have safety guardrails put in place in the open weight models. The challenge is the moment they are released and downloaded, people will fine-tune and jailbreak them. So no matter what we try and do, and no matter how we try to wrap guardrails around this, the nature of open weight models means these risks are ever present. So it's quite a big societal trade-off that is going on here. So they ask, is there a safe path to open the weights of powerful models when the misuse risks are real? We think that a path exists, though we have not mapped all of it. The central idea is that safe release depends on the model and the ecosystem around it. Is the model safe? Robust safety testing, an imperfect but essential proxy for real-world capability in dangerous domains, must be a necessary part of our model release process. What harmful tasks can it complete? How accessible is it? What happens if guardrails are removed? More broadly, additional safety research is needed. For example, we are particularly interested in whether dangerous capabilities that depend on specialized knowledge can be reduced through pre-training data curation or post-training interventions. This remains an active research question rather than an established solution. So here they're talking about the safety testing that all labs are doing before they're releasing models, both closed weight and open weight. And it is really important that some of the more dangerous capabilities are tested and there is some sort of post-training intervention for the absolute worst ones. But where exactly does that trade-off point lie? It's still not clear, and until there's potentially a really bad cyber event from a fine-tuned open weight model, we might just find out after the fact that safety testing around a particular suite of open weight models wasn't strict or severe enough. Is the ecosystem ready? Readiness means layered defense. The first layer is to enable individual organizations to patch their systems early or catch attacks in progress. Defensive research adds another layer, developing tools and techniques that let AI models themselves strengthen defenses at scale. These are just two of many layers. To prepare the ecosystem with layered defenses, we plan to collaborate with the safety community and provide access to capable models. So this is where they're bringing into their release process third-party safety testing firms to give that independent verification and assurance. Now, one important call out here is that all of this is essentially still quite voluntary. There's a teeny bit of regulation, but there's nowhere near the level of regulation we might expect in something like banking or aviation. So it's always worth bearing a lot of this in mind. We're on a frontier where AI labs have a lot more freedom than many ordinary reasonable people would expect based on some of the risks that exist around the misuse of AI models. Okay, how did they assess Inkling? So they concede that Inkling and Inkling Small are not the most capable models, but just because that's the case doesn't mean that bad actors still can't take those models as a base and evolve on them. So they did their own external and internal evaluations. They had 4 different external testing vendors and a fine-tuning study to try and figure out what the worst-case capabilities are, and they concluded that Inkling wasn't likely to add material risk beyond what existing open-weight models already pose. So here they're talking about their internal safety evaluations. These are similar to what the other AI labs disclose in their model safety cards. So things like CBRN, offensive cybersecurity, and misuse around harmful content and agentic behavior. They also have their own multimodal content evaluation, testing models on harmful prompts, and also did some external red teaming in 4 areas: general misuse, vulnerable user interaction, CBRN and cybersecurity, and loss of control behaviors. So all of these sorts of evaluations are part of the standard process across the industry, at least for the labs which disclose this at this level of detail. And this is essentially what you might want to call the bare minimum, the most reasonable expectation we can have of AI model providers, that at a bare minimum, they really should be doing all of this and disclosing what they safely can about the results so that the public is informed and aware. They also did some adversarial fine-tuning to help understand that balance around capability, accessibility, removing safeguards, and ecosystem readiness. So decoupling dangerous capabilities from general intelligence, they are talking about whether removing information at training time can reduce the incidence of dangerous capabilities ending up in the final model that's shipped, but they're saying it's still an open research question. Supporting the safety ecosystem with staged releases. So this is where they release the model over time to different parts of the population. So first it'd be their external safety testing partners, then API access, then monitored API access for a wider population, and then do an open model release. They also talk about their fine-tuning API like Tinker, which they've built to help people fine-tune models. So they're saying that adds a stage between inference and open weights and give the labs more time to understand how things are used and build out better understanding of some of the potential edge cases and misuse categories as well. And they go on to further explain what's happening in each stage and where they think they fit. Building the safety system ecosystem together. So this safe path to open models only works if the ecosystem's defenses improve as quickly as the models do. It's a pretty big if. We will do our part, deciding carefully what to release and researching how to decouple intelligence from dangerous capability. So that's that open research question that I referenced earlier. However, most of the work above happens outside our lab, and much of what this post describes builds on other people's work. For example, data filtering, our external pre-deployment safety testers, the framework for fine-tuning safety, and countless others working on cyber defense. No lab builds this path alone. Each new defense lets us open models that were previously too risky to release. This takes many more hands than ours alone, and we want to support that work broadly. We will shortly launch Tinker Safety Grants, funding for the community to strengthen the ecosystem's defenses. If you do safety research, our Tinker platform makes it easy to study fine-tuning and its risks. If you defend systems, we want to give you a head start. If you evaluate models, we want you to scrutinize ours. So what I think is super interesting is that Thinking Machines have released a strong open weight model family. They're going to be building on that. They're not at the frontier level, but they're quite open in thinking about how all of this works, some of the misuse risks, and the steps they're taking to try and reduce those risks. Given the massive explosion in interest in open weight models over the last few months, there's going to be more and more interest in exactly how all of this will work, and I'd be interested in hearing from you what you think about this. If you've tried out Inkling or Inkling Small, what do you think about them? If you're interested in more read-throughs and commentary like this, hit that like and subscribe, and I'll see you in the next video.